and welcome to my presentation. My name is Harpreet Mahal, and my topic is Project Soli. Before I get into Project Soli, I'd like to talk a little bit about Google ATAP. ATAP stands for Advanced Technology and Projects. This is the group that worked on Project Soli. They might have also worked on your project. Some of their work includes Project Jacquard and Project Ara. ATAP usually does work with the mobile technologies, mobile hardware technologies. And the reason I brought this group up is because they're pretty unique because they only get 2 years to work on their project, unlike other Google groups that get about 6 years. So after 2 years of research and development, it is determined whether this technology would be continued for future products or it won't be used at all. So now let's get into Project Soli. What is Project Soli? Project Soli is a tiny chip that uses radar technology to make touchscreen devices touchless. Soli was first introduced at Google I/O in 2015. At the launch, Google used an LG watch and a JBL speaker to showcase Project Soli's capabilities. So let's use the watch as our example right now. So on the watch, the tiny little chip would be implemented, and that chip would use radar technology to determine the hand position and detect what gesture was being made. And now that gesture allows you to control your device. So all the functions of your watch will now be controlled through touchless gestures. So for example, if I make a pinching motion, that pinching motion may let me zoom in on a map or zoom out of a map. Or dragging my thumb across my knuckle may allow me to shift the screen. So Project Soli also lets you, it also determines how much force you are using in your gesture. So if you're doing something rapidly, you might want to change your volume really quickly or lower really quickly. So let's talk about the radar technology for a minute. What is radar? Radar stands for radio detection and ranging. According to All About Circuits, a radar is capable of interpreting an object's position and motion even through other objects. Radar is typically used to determine the weather. It's used to detect missiles and planes, and it's also used by police officers as a speed detector. Radar is typically way too large for a wearable, it's usually the size of a desktop. So Google worked with a company called Infineon. Infineon's a company that works on semiconductors and systems. Those two teamed up and they developed a chip that implemented radar technology, and it was about the size of a dime. So now this small size made it perfect for wearables. So now you can put it into a watch, you can put it into something like a Fitbit, even into phones and laptops. So let's look at how Project Soli works. You can see the frequency waves there. So I'll give you a quick low-level breakdown. It's quite complex what goes on in the chip, but I'll do my best to explain how it works. So the chip first, it gives off a beam, and that beam is reflected back by the hand gesture. The reflection is then interpreted by the chip using a complex machine learning algorithm. This determines what type of gesture is going to be used and how much force is within the gesture. So now the gesture is relayed to the device, and now the device does what the gesture determined. So as I mentioned before, if the gesture was to pinch in and out, it might tell the device to zoom in and zoom out. So let's look at that in action. As you can see, the beam is sent, it's reflected back, then it's determined by the chip. Then after the determination is sent to the watch, and the watch conducts the function that was determined by the gesture. So now let's look at the gestures, which is one of the most important parts of the project. Soli uses a universal set of gestures to control their devices. So as I mentioned before, dragging across your knuckle to swipe the screen. It's mostly you're simulating the touchscreen gesture, the touchscreen without touching the screen. So you'll swipe across by just rubbing your finger across your knuckle, and you'll maybe if you want to move the volume, if you want to put the volume up, you would click your hands together. And Project Soli has a software development kit for developers, so they can use custom gestures that's best built for their product. the closer your hand is to your device, the more precise your movements will be, and the better it'll be able to detect how much force is behind that movement. So let's look at the future of Project Soli. The future is it's almost been about 2 years since the project came out. So we're getting near the time we'll find out what's the fate of Project Soli. There hasn't been much information about it recently, but there has been some ideas regarding the project. For example, using it on autonomous cars. As you might know, radar is perfect for detecting massive objects at miles away, and radar is used by police to detect speed. Autonomous cars is a possibility in the future. However, it's not so clear about smartphones and desktops and laptops. These are much smaller devices. As I mentioned a few seconds ago, the radar is best for massive objects at a distance. So they're still working on how these tiny devices can detect precise hand gestures only from a few inches away. So that's one of the problems Project Soli is running into. But there is interest there. So JBL offered their speakers and LG offered their watch for testing purposes. So there is some interest within the industry. Just we're not sure what's the next step for Project Soli. Here's a look at some of my references. I definitely recommend checking out the references and taking a look at the videos. Also, in the All About Circuits, it's if you're interested in the internals of the chip, it'll give you a nice walkthrough of how exactly it works, which is pretty neat. And there's also more information on ATAP. Thank you for watching my